Hello students, in this video we will see again how to find the moment of the forces given, and in this example we will see the couples which are given as well. Now these couples will be considered only during the time of calculating the net moment, and these couples are not going to have any effect on the resultant. This example, we can see that we need to find the resultant of the force system given. Now, to find the resultant means we need to find the resultant of the forces as well as the moment. Now, I have four forces, F1, F2, F3 and F4, and there are three couples also given to me. The direction of the couples is shown in the figure over here. Now, one thing we need to understand about these couples is we need to find out in which direction the unit vector for this couples is acting. Now, for example, C1, I need to understand the unit vector direction for C1, and for that we will be using the right hand rule. Now, in this case, I will take the right hand and I'll curl the fingers in the direction of the couple. So the couple is going like this. So I'll show the curling fingers going inside with my thumb pointing upwards. So the unit vector will be going from E to D. It will be from E to D. Similarly, if I say for C2, in this case, the couple is acting like this. So if I take the right hand and curl the fingers in the direction of the couple, so it goes in like this and my thumb is pointing towards this side. So the unit vector will be along OA. Whereas if I see for C3, again the couple is acting like this. So when I show it like this, it will be going inside and my thumb will be pointing in this direction. So again, the couple unit vector for C3 will be along EA. So I hope you have understood the concept behind finding the unit vector. I mean, how to find the unit vector for the couples given. We have to just use the right hand rule. We have to curl the fingers along the direction of the couple and our thumb will follow the direction of the unit vector. Now to find the resultant, we have seen that in many examples it is nothing but the summation of the force vectors. We have four forces in this case: F1, F2, F3 and F4. F3 and F4 are acting parallel to y-axis. One is towards the positive and one is towards the negative side. So I can directly write the force vectors for F3 and F4 as positive 40 j cap and minus 40 j cap. Now to find the resultant, we need to take the force vector summation of all the force vectors, that is F1, F2, F3 and F4. F3, it is parallel, F3 and F4 is parallel to y-axis. So this will be plus 40j and this will be minus 40j. The magnitude for F1 is 100 and the unit vector along which it is acting is AE. So this will be 0 minus 3, 0 minus 0 and 4 minus 0. F2 magnitude is 20 newtons and it is acting from A to C. So the unit vector will be C minus A. So it is 0 minus 3 I plus 2 minus 0j plus 0 minus 0k. F3 is 40j and F4 is minus 40j. So this will be 5. 100 by 5 is 20. 20 into minus 3 will give me minus 60i. This will be 20 into 4, so that will be 80k. Then this value over here plus 5.54 into minus 3i plus 2j, and this will be as it is, 40j and minus 40j. So minus 60i plus 80k. I'll simplify this. This will cancel out, so I won't write this now. So the simplified part will be minus 76.64i, and this will be 9 plus 80. Sorry, I'll take this term first, j 11.08j and 80k. So this is the resultant vector that is acting for these 4 forces on this force system. Now I need to find out the moment. The moment will be done in the similar fashion, and that will be taking the cross product of the force vector and the position vectors. So I'll write that. Moment vector about origin for all the forces will be summation of moment about O for force F1, moment about O for force F2, F3, F4, plus the couples which are acting in the system, that is the 3 couples C1, C2 and C3. Now I'll write each moment vector separately over here. Moment about O for force F1 is nothing but position vector. For force F1 I am doing position vector, I'll take it as OA. So OA cross F1. So this will be nothing but I, J, K, 3, 0, 0. Force vector F1 I have calculated over here. Force vector F1 is coming out as, in this example I have seen, it is coming out as minus 60i and 80k. J term is 0. So I'll write it over here, minus 60, 0 and 80. So this will be simplified into as I term is 0, minus j cap will be 240 minus 0 plus k cap will be 0, 0. So this becomes nothing but minus 240 j cap. Similarly, moment about O for F2 will be position vector for F2, that will be, again I'll take it as OA. So this is OA cross F2. This will be I, J, K. the position vectors will be same, so 3 0 0, and the force vector F2 is over here, that is minus 16.64 and 11.08 J. There is no K term in this case, so it will be minus 16.64 and 11.08. So if I simplify this, I'll get I term as 0, J term will be 3 into 11.08, 33.24, this is 0, plus K term will be, I'm so sorry, J term should be 0, I'll write it over here again, I term is 0, J term is 0, K term will be 33.24 and 0. So 33.24, which is nothing but 33.24 K cap. Similarly, I can do it for F3, moment about O for F3. The moment vector is given as cross product of, I'll write it over here, RO for F3. F3 is going from E to D, so I'll take it as OE cross F3 vector. So this is nothing but OE will be 0 0 4, and F3 I know is 40J, so this is 40 and this is 0, so I term will be 160 minus J, 0 and 0, plus K will be again 0, so I'm getting this as 160 I. So this is how I have calculated the moment vector for three forces. The last moment vector that is left out is for F4. I'll write that as well. Moment about O for F4 is position vector for F4. F4 is going from B to A. I'll take A because I know the position vector is 3 0 0. That is easier for me. So OA cross F4. So this is I, J, K, 3 0 0, and this will be 0 minus 40 0. So I is 0, J will be again 0, K will be minus 120, so I'm getting it as minus 120 K. Couple 1 is acting along ED, and that is parallel to y-axis positive side, so the couple vector I can say will be 20 J cap. So I'll just write it over here as 20 J Newton meter. Everything is in Newton meter over here. I'll write the units as well. This is Newton meter, this is Newton meter, and the calculation over here is minus 160 I, so Newton meter. Now C2 is acting along the x-axis, and that is the unit vector I have shown you is going on this side, that is positive x side, so I can take it as I cap, so that will be C2 40 I. I'll write it as C2 is 40 I Newton meter. C3 will be, now C3 is acting along EA. Now see, if I'm taking the couple like this, so the unit vector is pointing from E to A, so the unit vector will be along EA. So I need to find the couple vector in this case, so that will be C3 magnitude dot product along EA. I know the magnitude for C3 is given to me as 80 dot product EA, so that will be 3 minus 0 I plus 0 minus 0 J and plus 0 minus 4 K. This will be 3 square plus 4 square. So 80 by 5 gives me 16. 16 into 3 is 48 I, and minus 4 I'm having over here. So 16 into 4 is 64. So that will be minus 64 K. This is the couple vector I'm having, Newton meter. Now all I need to do is take the summation of all these moment vectors to get the net moment. So moment about O for all the forces will be, I'll take all the I terms first. In this case I'm having, this is J, this is K, this is minus 160 I. So I'll take this as minus 160 I as the first term. Over here I'm having 40 I, so that is positive 40 I plus 48 I. Then I'm having the J terms over here as minus 240 J. Then over here it is 20 J, so minus 240 J plus 20 J. Over here there is no J term. Now I'll go for the K terms. K term over here is 33.24 K, so that will be 33.24 K. I don't have any K over here, I have one over here, so that will be minus 64 K. So the net moment that I'll be getting minus 220 J and K will be Newton meters. So this is how we have calculated the net moment for the given force system wherein we had the couples acting in the force system. This is the net resultant that we have obtained for given force system wherein we did not consider any of the couples acting in the system, because the resultant is basically for the forces which are acting and the moment considers the couples which are acting in the system. I hope this different type of example is clear to you all. Thank you.